Ask the engineers who built ChatGPT exactly why it said one specific sentence. They can't tell you. Not because it's a trade secret. Not because they're hiding something. Because right now, nobody fully can. Every major AI system makes its decisions inside something researchers openly call a black box, and even the people who built it are still trying to figure out how to see inside. Here's what's actually happening under the hood. A large language model like GPT-4 or Claude isn't a set of rules someone wrote down. It's a neural network, essentially billions of numerical values, called parameters, adjusted automatically during training until the system gets better at predicting language. Nobody sits down and writes, if the user asks about cooking, respond this way. The behavior emerges from those billions of numbers interacting in patterns too complex for a human to trace by hand. That's the entire source of the problem. The system works. Explaining exactly why any single output happened is a completely different and dramatically harder question. For years, that difficulty had a name in AI research and a pretty bleak reputation to go with it. The black box problem. Early interpretability researchers tried looking at individual artificial neurons inside these networks, hoping each one might represent something simple and understandable, like this neuron detects sadness. Instead, they found something messier. Individual neurons often fire for combinations of totally unrelated concepts simultaneously. One might activate for both birthday parties and obscure chemistry terms, a phenomenon researchers call superposition. The model was cramming far more concepts into its structure than it had individual neurons to hold them, spreading meaning across overlapping combinations instead of clean, single locations. This wasn't a design mistake. It's actually a highly efficient way to pack an enormous amount of knowledge into a limited amount of space. It also made the resulting system almost unreadable to humans trying to inspect it from the outside. And this wasn't just an academic curiosity. It had already caused real, documented harm in systems making decisions about people's actual lives. In 2019, researcher Ziad Obermeyer and colleagues published a study in the journal Science examining a widely used healthcare algorithm, built by Optum, deployed across hospitals nationwide to flag patients who needed extra medical care. The algorithm used predicted healthcare costs as a stand-in for medical need. The problem, Black patients, for reasons rooted in unequal access to care, historically cost the healthcare system less than white patients with the exact same level of illness. The algorithm read that lower spending as lower need, when it actually reflected unequal access, not better health. Obermeyer calculated the bias reduced the additional care Black patients received by more than half. Notably, nobody had explicitly programmed the algorithm to consider race at all, and race wasn't even one of its input variables. The bias emerged anyway, hidden inside a decision-making process nobody had fully mapped out. In 2018, Reuters reported that Amazon had scrapped an internal AI hiring tool after discovering it had taught itself to penalize resumes containing the word women's and to downgrade graduates of all women's colleges, having trained itself on a decade of resumes submitted mostly by men. Neither company set out to build something discriminatory. Both discovered the bias only after the system had already been running, because nobody could simply open the model and read its reasoning directly. So has anyone actually made progress opening this box, or is it permanently sealed? Real progress exists, and some of the most significant work has come out of Anthropic, the company that builds Claude. In 2024, Anthropic's interpretability team published research demonstrating a technique called sparse dictionary learning, essentially training a second, smaller model specifically to unscramble the tangled, overlapping features hidden inside a large model like Claude. Applied to Claude 3 Sonnet, this technique identified millions of distinct, genuinely interpretable concepts living inside the model, everything from specific cities and scientific ideas to abstract concepts like sycophancy and deception. Their most famous demonstration became known as Golden Gate Claude. Researchers identified the specific internal feature that activated whenever the model was discussing the Golden Gate Bridge, then deliberately amplified it. The result: Claude began steering nearly every conversation back toward the Golden Gate Bridge, even when asked about something completely unrelated. Direct, visible proof that a specific internal concept had been located and could be manipulated on purpose. That's a genuine breakthrough. It's also nowhere near a complete solution. Even Anthropic's own researchers describe this as mapping a small fraction of a much larger, still mostly unexplored space. Millions of identified features sounds enormous, until you consider that a model this size may contain many times that number of meaningful internal concepts, interacting in combinations nobody has cataloged yet. The honest current state of the field: we found a genuine way to open small windows into the box. We still can't see the whole room. Which raises a serious, practical question, well beyond academic interest. What happens when a system nobody fully understands starts making decisions in courts, hospitals, and government agencies? Several U.S. states now use AI-based risk assessment tools in bail and sentencing decisions, tools that have faced direct legal challenges from defendants arguing they have a right to understand exactly how a system that helped determine their sentence actually reached its conclusion. The European Union's AI Act specifically requires that high-risk AI systems, including those used in hiring, credit, law enforcement, and healthcare, provide a meaningful level of explainability to the people affected by their decisions. Similar right to explanation language already exists under Europe's GDPR framework for automated decisions generally. The tension is direct and unresolved. Regulators increasingly want AI decisions explained in ways courts and citizens can understand. Current interpretability research, even with real breakthroughs like Anthropic's, still can't reliably deliver that for the most powerful systems in active use today. The black box problem isn't a permanently unsolvable mystery, and it isn't something anyone is deliberately hiding either. It's an active, moving frontier of research, one where genuine progress keeps chipping away at a genuinely hard problem, without yet fully solving it. Until that changes, every AI decision shaping a loan approval, a hiring choice, or a sentencing recommendation is still, at some level, a judgment call made inside a system its own creators are still learning to read. If that changes how you think about the AI systems already making decisions about your life, that's exactly the right reaction to have. Subscribe for more deep dives into the parts of AI that even the people building it are still figuring out. And tell me in the comments, should AI be allowed to make high-stakes decisions in courts or hospitals before this problem is actually solved?